The AT Model 1 Water Blaster project is a senior design project sponsored by Great Big Kid Toys, advised by Dr. Kallmeyer and Dr. Wang, and team members which include Dylan Cummings, Tyler Athmann, Alex McIntyre, and Bryan Olstad. Main project requirements is that the blaster needs to look fake, water needs to be stored in a 2-liter pop bottle, it also needs to have a continuous and intermittent stream of fire, and the continuous stream needs to reach at least 20 feet. Initial research was to determine whether we go with the water blaster or foam dart blaster. After research with patents and the market, we found that the water blaster would have a better opportunity to serve for the market. The next step was to generate 4 concepts. All concepts included a water pump, battery pack, a general intermittent design, and a 2-liter pop bottle for a water tank, which were all in different configurations. Higher detailed intermittent designs were created later. 2 intermittent ideas were designed further for testing. For the first design, a DC motor rotates a plastic wheel into the line of water. A pen cap was used to push the DC motor up and down to generate a solid and intermittent water stream in the same design. The second idea was to power an originally closed solenoid to start and stop the water flow at a specified time increment. This was purely electrical. For testing, 3 different pumps were purchased to see which would project water the required 20-foot length. To reduce issues with water and the electrical wiring, a test stand was made to easily test other components such as various nozzles and 2 intermittent designs. When testing, issues were found with supplying enough air into the pop bottle without crushing when water was pumped out. The new requirement was then set by the sponsor to create a tank that can be removed from the launcher. The next step for the project was to 3D model the shell, tank, handle, intermittent design, and other internal components on Creo. Parts were then brought to the NDSU Project P lab where they were printed with PLA filament. For the tank and intermittent designs, models were produced on an SLA and MJP printer due to the PLA not being able to handle water effectively. After printing, some 3D parts needed modifications. Once completed, all components and electrical connections were put together. The fully assembled water launcher was then tested to assure all requirements were met. The launcher's weight was under 5 pounds, the water distance was well over 20 feet, and it took 1 minute and 20 seconds to empty the tank on solid stream mode. For future work, a more attractive design can be created, improvements can be added to the intermittent designs, and large-scale manufacturing of this product can be investigated and set up. We want to thank Gary Johnson for sponsoring this project, Dr. Kallmeyer and Dr. Wang for mentoring the group, our professor Dr. Ulven, and everyone else that helped us along the way.